Hello, welcome back to Cracking the Cryptic, and really interested in today's puzzle called Killer Wasp by Quarter Through. And we'll have a look at that in a moment. Now, there is, of course, our fantastic Patreon puzzle hunts going on, Sudoku hunts. One is Jovial's brilliant extravaganza of puzzles. And the deadline on that is the 20th of July. So that is the deadline. We will at that stage be drawing out a winner from the hat to receive the incredible Sudoku pillow created by Anita that features the first puzzle on it in Sudoku. I absolutely love it. If the winner doesn't want it, I might definitely seize that. No, that won't happen. But that's coming up on the 20th. But those puzzles have been there for 10 or no more than that days, and hundreds of solutions in. So don't think you're definitely going to win if you get the right answer. It may be hard, but we've got a lot of brainy people working their way through. The same is true of the murder mystery hunt, cracking the case of the Roman tragedy, curated by Alison No Feet McGee. Fantastic story there, and puzzles to go along with it, some approachable Sudoku in all the different styles that you see on the channel. Again, that one is free on Patreon though. It's not just for the paid patrons. Do check out our Patreon site. Do support us if you're kind enough to. We are always very grateful if anybody supports us in any way on that channel with money, and thank you. And of course, there's always the Discord server and all our apps, all on the links under the video. Now, this is called Killer Wasp, and I think as we received it, I'm sorry to Quarter Through, because I haven't shown the cage shading. I am pretty sure that it's meant to be something like this, and apologies if I get it the wrong way round. But as we received it, the cages were all given colours, and you can kind of see let's assume it's like that. This is the waspy nature of the puzzle, is that yellow and black kind of shading, but it's probably easier to solve, to be fair, without the colours, especially given that there is a grey cell marking an even digit. So let's just have a look at the rules, which are that normal Sudoku rules apply. In cages, digits don't repeat, and the cages show their sums. This grey cell represents an even digit, and that's it. So it's basically Killer Sudoku. And this is by Quarter Through. We've solved his puzzles a number of times on the channel, and they are always good value. Do give this a try on the link under the video. I'm going to start now. Let's get cracking. Well, okay, this seems to focus more on the high numbers, does it? I mean, this one, that's the only cage we know the candidates for. That has to be 98764. 9876 add up to 30. That's worth learning. And if you've got a fifth digit, it must be a 4. Does that... I suppose 1 in this box has to be in one of those cells. Doesn't really do much to this cage, does it? Again, these are quite high numbers, but they are not high enough to force 9. I don't know that they're in the right shape to force 9 anywhere either. Maybe, oh look, 18 and 9, these are quite low, so there has to be a 1 in the 18 cage, doesn't there? Oh no, I tell you what, it's like this, isn't it? Of course, it's the symmetry with that. There's no 9 in the 9 cage, there's no 9 in the 18 cage, so we get a 9 in one of those 3. Does the 29 have to have a 9 in? No, I don't think it does at all. 8, 7, 6, 5, 3. is 29. If this 29 cage wasn't 87653, there'd be a 9 there, no 9 there, there'd be a 9 there, the 19 cage wouldn't have a 9, and it would feel like you could do something. So 19 is quite big, 34 is quite big, 29 is quite big. Oh, hang on, no. You see, this is an interesting arrangement, isn't it? I do not associate quarter through with set theory. And I think I might have to learn something about that today. It's very interesting. This 20 and 10 add up to 30 as well. Look at these shapes. This is interesting. Right, let's colour some colours. I might be on the wrong track here, but I'm going to do this anyway. These shapes. Down here in green we have some quite big numbers for 5-cell and 3-cell cages, 29, 34 and 19. Up here in blue we have some quite small numbers. And that's interesting because these sets of digits have to be exactly the same, and I'll explain how I know that. Consider rows 6 to 9, which obviously contain the digits 1 to 9 4 times. But then take out this little section that I will colour red. And what are you left with? You're left with green. Consider columns 1 to 4, which contain the digits 1 to 9 4 times by virtue of being 4 columns. And take out the red section of digits and you're left with the blue section. So that proves that the blue section and the green section in this puzzle must contain the same digits. So they've got to add up to the same number. And this is where this either falls flat or is very interesting. 41, 59, 68 in the marked cages. Now let's remember these are not marked, and that's the same down here. But 68 in the marked blue cages. In fact, maybe let's just take out those colours. 68 in the blue cages, 29, 39, 73, 83, 92 in the green cages. So 92 minus 68, the difference between the marked cages and therefore the difference between these two sets of digits, so the difference between purple and orange, is 92 minus 68 is 34, which is too much. Hang on, 92 minus 68 is not 34, no, it's 24. Thank you. Sorry, I made that mistake. 24 is not quite enough. This is very disappointing. Right, why am I saying 24 is not enough? Let's imagine these were at their maximum to make up these numbers. They could both be 9 and 8 in both places would add up to 34. So 9 and 8 in box 1, 9 and 8 in box 5. That's 34. These could be 1 and 2 in both boxes in the same way. They'd add up to 6. And there's a difference of 28 there, which is disappointing because I was hoping that difference would be 24 and we could start filling in numbers. Oh, hang on, these can't be 1, 2 though, because of this 10. 10 needs a 1 or a 2 in it. Yes, okay, and these can't be 9 and 8 because of this 20. Hang on. That's going to get rid of those 4 degrees of freedom. That is amazing, by the way. This is amazing from 2 points of view, that I have hit a set theory thing straight away and that it works so beautifully. Right, what I'm saying now is I needed the difference between these orange and purple cells. Well, because the difference between green and blue is 24, because the two rectangles must contain the same digits. Therefore, the difference between orange and purple is the same difference as between the cage totals, and it is 24. Now, if I was to minimize these, I can put 1 and 2 there. I cannot put 1 and 2 here because the minimum sum for that 10 cage would then be 12. In fact, these 5 cells have to add up to a minimum of 15, so these have to add up to a minimum of 5, made up of either 1, 4 or 2, 3. With 1, 2 there, these purple cells now add up to a minimum of 8. These orange cells, 9 and 8 there, these 5 cells add up to 35, take out maximum, take out the 20, these two add up to 15 maximum, either 9, 6 or 7, 8. And with 15 there and 17 there, that's 32. And with 3 there and 5 there, that's 8. And that is the absolute, that's the difference. So these must be maximized. These orange cells must be maximized like that. These purple cells must be minimized like this. And we have started this puzzle. These two add up to 5. These two add up to 15. We have 1, 2, 3, 4, 5 sets here. So 4 is not there. We've got a 9, 8, 7, 6 quad. We've got a 1, 2, 3, 4 quad up there. 4 must be in that group of cells because it's not there now. This 13 cage has to be 3, 4, 6 because it can't contain 1 or 2. So then we have 5 and 7 in the rest of the box. Now, this doesn't have a 4 in it. This 19 sum, that's not that helpful. Does it have to have a 9? It could, no, it doesn't. It could be 8, 7, 4. Right, so what next? 4 is in one of those, so it's not there. It's there. There's my first digit, a 4. If that was 7, you can't have a 7 here. This could be 1, 2, 3, 5, 7, could it? Yeah, it could. Okay, that's not resolving anything. What about this? It doesn't have 1 or 2. Tricky. Oh, hang on. 4 there, 4 there. Right, there's a 4 up here. That's brilliant. That means there's not a 4 there. That means there is a 4 here. And that means this cannot have a 7 in it because the other 4 digits would have to add up to 11 and would be 1, 2, 3, 5. I.e., it can't have a 7 and a 4 in it. So there's no 7 there. There's no 7 there. There is a 7 here. And that's not a 7. 5, which really blows Simon's theory out of the water that the more clever a puzzle is, the more likely it is to have a 5 in the central cell. But that's very unfair. He's not really claimed that, I don't think. 7, so there is a 4 here. Could there be an 8? If there isn't, we get a 7, 8, 9 triple here. But if there is, it's 8, 1, 2, 3, 4 there. I suppose that is possible. Now, should I be able to do the same? Yes, look, 5 there. So I've got a 5 in this 19 cage now. Okay, so it's 5, 6, 8. It must be. Right. So 6 and 8 are not in these cells. I should have known 6 wasn't from there. So that is a 6, 8 pair. This is a 7, 9 pair. That fixes this cell as a 4. This is not fixed. That can't be a 4 though, so that's not a 1 because those two add up to 5. 4, 7, 9, 5, 6, 8. This is now a 1, 2, 3 triple. This is therefore 4, 6, 7, 17. These add up to 4, so they're 1, 3. That gives us 2, 4 here. 6. So these add up to 12. I think they've got to have a 1. Otherwise they'd be 3, 5, 6 at a minimum. So there's definitely a 1 in there. That makes this 9 cage 2, 3, 4. 6 and 3. Now they don't have a 3. I think they've got to be 1, 5, 6. And this is 7, 8, 9. 3, 4, 6 here. Let's check that sum. 13 and 16 is 29. Yes. Right. 1, 5, 6, 4, 3. I haven't resolved that or that pair. So the symmetry looks like it's working very well. 7, 6, 1, 5. I'm putting in all the candidates here just in case it helps. Right. The 20 cage can't have a 2 in it. So there is a 2 in this odd shaped 32 cage. Let's have a look up here as well. Same sort of thing. 1, 2, 3, 9 are the candidates. 3, 6, 4, 7, 9. 1, 2, 5, 8 there. So again, this can't be 1 or 2 now. That doesn't give me a definite number that's gone into the 32 cage. So the symmetry is being broken a bit. Should I have been able to solve this? It's not 2 or 4. Nearly. Not quite this time. So it's not quite entirely symmetrical, this puzzle. But it is very neat and clever. I mean, it really is. Okay, so this 20 cage now. If that's an 8, that's a 5, that's a 7. 3, 6, 7, 8, 5. Oh, that is really disappointing. I was just looking at the... Oh no, hang on. 6 and 8 are looking at that, so that's a start. 3, 5 or 7 there. Oh, in fact, that can't be 8 because of that 6, 8 pair. That might be more helpful. Right. In fact, okay, yes, I was going to point out that this was odd and that was even. Therefore, I could work out the parity of that, but I've already done that. No, hang on, this isn't always even. This is much better. If those two are odd, this is definitely even. It must be 8. I think this is right. Let me just go through. So 8 there seems to be impossible. No, 8 there is right. 5 is impossible because these two would have to add up to 15 and they can't use 6 or 8. Yes, that is fine. So 8 is there. These two add up to 12, so that's not a 7. They're either 3, 9 or 5, 7, so that doesn't actually resolve. Oh, that can't be a 6. Doesn't resolve much else, but there's no 8. Oh, we've got a 2 already in this cage, so there's no 2 there. That's a 1, 5 pair. Brilliant. So now we get 2, 3, 9. We fix this purple 1, 2. Right, 1, 5. It's not really resolving that even cell. I mean, we know it can't be a 2 already. Now, 32 is missing 2 of the numbers from 1 to 9 that add up to 13, but it's not missing 5 and 8. So it definitely has an 8 in it. It's either missing 6 and 7 or 9 and 4. So it definitely has a 3 in it. And that means this cell doesn't because it's in the same box with another 3. So we've done the 20 cage. 5 and 7, and that doesn't do anything else. Oh, hang on, it takes 7 out of there. So 1, 5, 3, 2. Oh, this almost is coming good. That can't be 8, so that's not 7. 6, 7, 9. One of these is a 1, and it's not in the cage. Yes. in row 3 we have to place a 1, and it's got to go there. That's not a 1. That just feels like a lucky spot. I mean, I don't know. Right, this is either missing 9, 4, 1, 5, or 6, 7. If it was I don't know which is more likely. It's more likely to be missing 6, 7. So if it was missing 9, 4, we'd have 1, 5, 2, 8, 6, 3, 7. Which looks possible. But if it was missing 6, 7, 6, 7, it's a lot easier to put 2, 3, 4, 8, 9 in there, isn't it? That's 3 or 9. Yeah, I don't think that's resolvable. Ah, hang on. Look, 9, 7 pair looking at a 13 cage. Wake up. 5, 8 there. So we get a 6 here. That is 1, 2, or 3. No, look at that. That's a lovely naked single. Because there's a 1, 3 pair here, 5, 8 there, 6, 4 there, a 7, 9 pair. That must be a 2. It's the only other digit it can be. Now, these 4 cells add up to 13 with a 2. They must have a 1 as well. Oh, and then either 3, 7, or 6, 4. So this has definitely got a 9 in it. And this is 1, 3, 7, or 6, 4, definitely with a 1. Okay, that wasn't quite... I thought I was going to be onto something here. Not really. Oh, that can't be a 2, so that can't be a 3. So we're narrowing these down all the time. 1, 3 pair. That is a 4. Okay. They can't have a 3 or a 4 now. Sorry, I can't even remember what the total of that cage was. 19. So 9 and 7 would give a 3. 9 and 6 would give a 4. 7 and 6 is not possible, because that would need another 6. So there is a 9 there. So that is in fact not a 9. In fact, it's 3 or 4 we just worked out. There is a 9 here, so that's not a 9, and that's not a 9, and we're getting closer with this pair up here, but not quite there. So that's a 9, 6, 7 triple in the column, so that's an 8. This can't be a 1. In fact, that's the only position for a 5 in the column. But these just don't have read across. We're still left with 2 possibilities in the orange and purple cells. Is it going to come down to this wretched 32 cage and it's even digit somehow? Now the constrained one is missing 9 and 4. Maybe the way to look at that is 9 and 4 would be in these cells if it's not in the cage. Maybe that's not the way to look at that at all. 2, 4, 6, 7, 8, 5, 1. This is 3 or 9. That's all it can be. 6, 8, 5, 7. This can't be a 1 or a 2, which is already in the cage. So that's 3, 4, or 9. So there is no way of putting a 7 in this cage. Is that right? Look, yeah, there's a 7 looking at that cell from that pair. There's a 7 looking at that cell. That is even. That's why it's an even cell. You can't get a 7 in it. Therefore, we're not allowed a 6 in it. And we do know it's 2, 4, 3, 8, 9. But that doesn't necessarily help us finish. We know what's in that cage now, though. So maybe that's created a quadruple, say, 1, 3, 4, 9, so we can put 2 up there. Has it created anything else? 4, 3, 8, and look, 8 must be in one of those 2 cells, so that's not an 8. That's not really, it's not really big news. Oh, hang on though, all of these see that, don't they? But I don't know enough about what that is. Okay, that didn't. How about all of those see? This is the only place for a 4. No, one of those 2 is a 4. So that's not a 4. So we know where 4 goes in the 21 cage. It goes there. One of those is definitely a 4. So this is 2. Oh, I don't like this. I'm just picking off digits one at a time and hoping something pops free. Maybe I can do better here. Or in these cells. Somehow these look like maybe they don't work one way around. If that was 8, that sorts them out going around the grid. 4, 2, 3. But I don't see why that would be a problem. 1, 2, 3, 4, 8, 9. We've definitely got 7 and 6 to put in these cells. Oh, this is not obvious to me how this is going to resolve. What a puzzle. Absolute sting in the tail. Classic wasp technique. It is indeed a killer wasp. What about this? If this is 2, 3, 5, then we get a 4 here. 8, 9, 3. Eight there would mean a 2-9 pair. That can't work. You can't have a 2-9 pair here because with 9 there, the other 9 would be there, and that is in the same cage as that 9. Wow, so that's a 2-8 pair. That becomes a 4, and that does resolve the purple. 2 and 3 there. That doesn't fix that though. Never mind. We've got a 3-9 pair up here. So this is 6, 7, 8. So the, no. 3-9 pair there doesn't look very helpful. Oh, surely this is doing it, isn't it? Yes, that has become a 4 since we did this 2-3 pair. That has become a 9. Yes, the 2-3 pairs looking at that. That does fix this. 8 and 7, because we know they had to add up to 15. This is 9. I think we are getting there now. Oh my goodness, what a brilliant puzzle. Really, really amazing. This, you see, I don't know. I'm not sure Quarter Through was doing puzzles like this originally. This has been incredibly clever. I mean, I'm not saying it wasn't clever before, but this was just weird and off the scale. Right, we know that they now don't have a 7, so this is a 4 to make up the 19 total. No 4 or 6 there. We get a 1 here. 3 and 2. Excuse me. I think we are just finishing off here, but I'm going to stop for a cough. So that is a 1. We are nearly done. Can't have an 8. That's a 5-9 pair. They've been resolved for a while. This is 1-4-5, and we know where the 1 goes. 4-5 pair there. 3-6 is resolved. Oh, I keep getting panicky that I'm seeing deadly patterns, but I'm not. 7-8. 8-2. So bottom 2 rows, they can't have a 6. 1 has been resolved down here. And that 1 is going to go up the grid. Yeah, and all of these pairs are getting resolved very prettily now. And we are going to finish this puzzle, which, thank goodness, that set theory idea was right, because that would be very hard to break in without spotting it, I imagine. Let me know if you did find another way through that puzzle without looking at these blue and green rectangles. Really entertaining. I think maybe we should colour them yellow and black just to commemorate the original Wasp theme. And it was waspish, it really was. What a good puzzle. Thank you so much to Quarter Through for sending that to us, and very much hope to see you again on the channel soon. Bye for now.